Thank you everyone for joining us. This is our third or fourth webinar kind of in this series. This is the first one that we're doing related to a really exciting new capability in Bitbucket Cloud called dynamic pipelines. We'll go over what that is in just a second, but before we do that, I'm going to do some intros. So my name is Edmund Monday. I'm a senior product manager on Bitbucket Cloud. I am the PM for the teams that have been building out this dynamic pipelines capability, as well as the teams that we've been working on some other things in this space called custom merge checks. With me is Ash Musa, who's Senior Product Marketing Manager for Bitbucket Cloud. We have Katarina Kurti, wwho is, I always get that full thing, you are a developer advocate in the developer experience team.
Yes.
And we have Ian, I'm not going to try and pronounce your last name because I'll get it wrong, sorry. But Ian is also from the developer experience sort of part of the business, and he'll be helping out with questions. He's also very active in sort of the community group, answering questions and things like that. So we have a full house today, and they'll be helping out with questions as well as some other stuff at the end. Quick agenda for today's session. So we've just done the intros. I'm going to talk a little bit about DevOps automation, which is a concept that we've been working on in Bitbucket Cloud that this sort of all falls under. We're going to go over dynamic pipelines at a high level, a conceptual level, go through some example use cases that are already being implemented inside Atlassian using this capability. We'll cover how to get started, and then we'll actually be doing some live coding at the end. Now, just to set expectations of everyone, this session is going to be a sort of an intro session because we haven't touched on dynamic pipelines much in the past. So there'll be a bit of extra time spent on these sort of first sections, and then the live code at the end will be a relatively simple example to get you up and running. And what we'll actually be implementing is the ability to enforce a Git secret scan across every repository in your workspace for every pipeline that's run from a single place. Next webinar, which will be in a few weeks, we're going to be diving into a more complicated use case, which is what we call selective test execution. So this is the idea that on a pull request, you would look at the change set that's being changed on the pull request, and then choose which tests you want to run in your repo based on the change set to reduce your PR cycle time, get your build times down, and make sure your team can move faster. So that's a more advanced use case, which we won't be touching on today. I will be talking a little bit about that in the example section. Today, we'll be sort of doing a nice gentle introduction to the actual building of the apps. And then the next time around, we will be diving into a bit more. We'll share a link to the sign up for that next webinar. So you can sign up to that now. You'll also see that around the product and blogs and things like that as well. DevOps automation is a concept that we're working on in Bitbucket Cloud, which basically is this idea that we want to build a platform, not just a product. So we want to turn Bitbucket Cloud into the most extensible code management and CI/CD product on the market. We think that as the software industry kind of evolves and becomes more complicated, it's nearly impossible for an off-the-shelf SaaS product to actually meet every single one of the requirements that any business has, let alone all of the businesses out there have. So instead of trying to do that and make sort of an overly complex, bloated product, what we're looking at is providing you with the tools to be able to extend the product with bespoke functionality where you need it to make sure that it covers the use cases that you have that are probably bespoke to your business. We talk to customers all the time, and we find that we've come across different use cases which are incredibly powerful and incredibly valuable, but also incredibly bespoke to the extent that it's just not feasible for us to go and build native solutions for everything. So what we can do instead is, because effectively all of our users in Bitbucket Cloud write code every day, we can provide you with really powerful extensibility mechanisms to let you build simple, easy to maintain sort of extensions that you can then set up as sort of plugins to Bitbucket Cloud that will then allow you to solve those specific use cases that are more bespoke to your particular scenario. We're achieving this using Forge, which is Atlassian's sort of in-house extensibility platform. Forge has been built over several years, and it was primarily originally built for our marketplace partners. We have a really, really thriving ecosystem of apps that are built for Atlassian products, and a lot of those are built on top of Forge. And so what we're doing in Bitbucket Cloud is we're obviously bringing this capability to our marketplace partners as well, but we're really focusing on how we can also bring this to customers as a feature rather than just a capability for marketplace partners. So because we're in the lovely position where most of our users write code, and code is in fact almost the preferred way of interacting with the system for a lot of our users, we see Forge as not just a tool for our partners, but also as a tool for our customers. And we're looking at a bunch of ways we can bring that to Bitbucket Cloud to sort of give you extra functionality. Touching really quickly on something called custom merge checks, which was the sort of the first main pillar of this DevOps automation strategy that we've been building out. So custom merge checks went into open beta late in 2023, and it went GA around about 2 weeks ago. So custom merge checks give you the ability to write custom rules, so that you can enforce your business logic as Forge apps, which are basically just little Lambda functions. and then have those enforced on your pull requests so that code doesn't get merged into your repository unless it passes all of those sets of business rules. I'm not going to go into custom merge checks here. There's 2 previous webinars we have on that where we code up some custom merge checks and I go into all the details. If your business has processes or rules or policies or compliance aren't a word, compliance requirements that it needs to enforce, custom merge checks are a really powerful tool to do that. And so I really suggest you go and have a look at those. There's plenty of information on YouTube, as well as the community group and all of the docs that we have published as well. Today, we're going to be talking about dynamic pipelines, which are a really exciting new capability, specifically for Bitbucket pipelines. So dynamic pipelines give you the ability to introduce intelligence into your CI/CD workflows at runtime. What we mean by that, we're going to go into in more detail, but basically it's the idea that a CI/CD workflow should not be a static process that never changes. There's a lot of value in having your CI/CD workflow as kind of this like declarative YAML type structure, but there's also a lot of value in having certain parts of it which you can make flexible. Some tools do this by giving you sort of lightweight sort of templating syntax you can put into the YAML, but there's a lot of limitations, that kind of thing, and you end up almost reinventing a programming language inside YAML, and it is not the greatest solution, and you hit walls pretty quickly. We're going a different approach, which is we are saying your YAML is for your static declaration of your pipeline, and it's not meant to be enormously flexible because YAML at the end of the day is actually a configuration language primarily. But if you want to make your pipelines flexible, you want to make them intelligent, we can leverage Forge for that. So what we do is we give you the ability at runtime, just before the pipeline runs, to actually take that configuration and then execute a Forge app, which can look at the context of your repository, it can call out to other systems, it can do whatever you need to do, and then make small runtime modifications to that CI/CD configuration just before it runs, so that then your pipeline is intelligent and it can adapt to your business's requirements or changes in the context. We'll go into more detail with some examples of exactly what that means, and you'll sort of get a picture for it. So just a quick FYI, both these capabilities are now in GA. Custom merge checks and dynamic pipelines both went GA on April 23rd. So these are available in the product today. You can try them out. Just one thing to note, dynamic pipelines is a Bitbucket Cloud premium feature. Custom merge checks is available for both premium and standard. However, there are some components of custom merge checks that are also premium only. So just get that out of the way. All right, diving back into dynamic pipelines. Excuse me for 1 second. It's very early here, so I haven't had much caffeine yet. So this is your current state of working with a CI/CD workflow in Bitbucket Cloud today. And this is the current state in most tools where you work with CI/CD. You'll have a repository that will have your code in it. And ideally, that has some sort of configuration file in it, which is your pipeline configuration. It can be Bitbucket pipelines, it could be for something like Jenkins, it can be whatever else, but it's going to be some sort of configuration as code stored in the repository. That's sort of your best practice today. What happens is when you want to run a pipeline, so you've got a pull request, the tool will grab that file, either JSON or YAML or TOML or whatever it happens to be, parse it into a workflow, and then execute that workflow on some kind of CI/CD engine. In our context, it's Bitbucket pipelines. That's been the model for probably, I would say nearly 10 years. It's kind of like the standard of how to do CI/CD. And it's worked really well, but it has started to run into some limitations. And we see this particularly with customers that have some more complicated workflows. As the needs of the business grow, as the complexity of the workflows grow, managing it all through purely static declarative files becomes really, really tough because you just start growing and growing and growing and getting more complicated. So we wanted to provide a way that allows you to add flexibility to your pipelines workflow and take advantage of all of the kind of nice benefits that programming languages give you, like code reuse, the ability to iterate over things, the ability to introspect things, which you don't normally have when you're working with YAML alone. So the way we're looking to address that, the way we do address that, is what we're calling dynamic pipelines. So what a dynamic pipeline is it's a little bit of logic implemented as a Forge function, which is basically a Lambda function. And it sits between the YAML file or the configuration file and your pipeline execution. So what we do instead is if there's a dynamic pipeline configured against the repository, we take that YAML file from the repo, we parse that into kind of its workflow structure, but then rather than running that directly into pipelines straight away, we actually call out to a Forge function and we pass that configuration, that workflow, to the Forge function as a JSON blob. That Forge function can then introspect that workflow and basically decide whether it wants to make changes to it. It can do things like call out to Bitbucket APIs to get additional information. It could call out to systems outside Bitbucket, either other Atlassian systems or non-Atlassian systems. It can have its own logic sort of embedded directly inside it. And you can even add your own configuration UI into Bitbucket Cloud using Forge UI extension points, which the dynamic pipeline can actually pull state from and can read data that you've stored in the Forge database. What that lets you do then is make changes to the pipeline at runtime. And this is, we're talking like seconds before it's executed, so that these changes are always reflective of the current state of the world when you actually execute it. It then simply returns an updated configuration. It can return the exact same one it got, or it can return one that has changes made to it. And we will then execute what it returns. So this gives you the ability at the repository level to massively simplify your actual static YAML file declaration, because you can implement a lot of the complex logic inside your dynamic pipeline using the tools that you're used to today with modern programming languages. It also means that your pipelines can be much more flexible and much more reactive to the state of the world. So for example, if you don't want to deploy after 5 p.m. on a Friday, unless there is a support representative available to handle any kind of on-call, what you could do from a dynamic pipeline is you could actually call out to your, say, support ticketing system, check the schedule, see if anyone is currently scheduled on call at that point in time. And if they're not, you could actually update the dynamic pipeline configuration to stop the deployment and not let it go out until someone is available. So that's an example of something that you could do very easily with the dynamic pipeline. Now, one of the really nice things about dynamic pipelines is because they're made as Forge apps, they can be reused across multiple repositories. So Forge app is installed at the workspace level, and then it's shared across all of the repos in that workspace, and multiple repos can opt into the same dynamic pipeline. Now that's great, and it is quite useful for code reusability, but it doesn't solve probably one of the most fundamental challenges for larger, more complex organizations when it comes to CI/CD, which is standardization and kind of orchestration of CI/CD across the entire workspace. And we really wanted to solve that problem as well. We wanted to solve the problem for the teams, but we also wanted to give organizations and companies the ability to set standards and minimum requirements across the entire organization, and then kind of orchestrate CI/CD across the whole organization, but critically without removing the autonomy of the individual teams at the repository level. And we're really excited with how we've been able to achieve that. I'll go over that now. So in addition to what we call repository level dynamic pipelines, we also have this concept of workspace level dynamic pipelines, which basically is the same technical concept, but it's implemented and it's sort of configured at the workspace level rather than at the repository level. Now, a few important things to note here is you can have both a repository level and a workspace level dynamic pipeline at the same time. They will both operate on the CI/CD workflow. So teams can implement their own team level logic, and then you can implement your own company level logic as well. And we will make both of them work for every single run. They're not mutually exclusive. And the way it's designed is the kind of order of priority starts bottom up. So we say, all right, the repository is sort of the baseline level. We'll take the configuration from the YAML file. We'll allow the repository level dynamic pipeline to make some modifications first. And because dynamic pipelines are designed in a way where what they get as an input is what they give as an output, we can actually chain them together, and they'll just work perfectly fine. So once the repository level dynamic pipeline has made some changes, say that's sort of team specific logic that your team wants to implement, we feed the output from that back into the workspace level dynamic pipeline, which is standardized across every repo in the workspace. And that's where you can do things like implement company-wide policies and processes. You can ensure that your CI/CD workflows are meeting your compliance requirements. You can also do things like you can create your own templating systems so that you can have your own sort of like sort of template syntax at your company or standardized reusable blocks of workflow. I'll go into one of those examples in a bit because that's something that we're working on here internally at Atlassian. But I really want to stress that workspace level dynamic pipelines are, in my opinion, and I'm biased to be fair, probably the most powerful tool that's available on the market across any product for organization level CI/CD orchestration today, because it doesn't take away any power from the individual teams. And it gives you one place where you can standardize and enforce policies and processes across the whole organization really, really easily. We'll go into that later on because the example we're actually going to code up today is going to be a workspace level dynamic pipeline. And I'm going to show you how easy it is to sort of implement one versus the other and toggle between them because it is really simple. All right, we're going to jump into some example use cases and then we're going to do some coding. So just to be clear, these are all example use cases that are being actively implemented inside Atlassian, sort of internal tools. As these things mature, we will be looking to sort of probably strip them out a little bit of some of the Atlassian specific logic, and actually list them as open source so that you can download these tools yourself as dynamic pipelines, and then use them as the foundation for your own tools as well. Now, the intention is that you don't need to have sort of us building these things and that you sort of adapt them. You should build your own things from scratch, but we do want to be sharing some of these more advanced use cases. We have some example dynamic pipelines apps already shared in our documentation, and we'll be looking to sort of build more of those and share them out. And so these are some examples of things that we're building internally. It'll probably be, just to be sort of expectations, a few months before these are sort of shared publicly, because we obviously have to make them stable ourselves, and then we have to remove quite a lot of sort of Atlassian specific stuff from them so that they're actually relevant. So the first one we're looking at today is something we call selective test execution. So what that is basically is the idea that on a pull request, you look at the code that changed, and you only run the tests you want to run for that specific code change. Now, if you work in a smaller team with a smaller repository, this might sound a little bit counterintuitive. Like, why would you want to reduce the number of tests you run? But if you work on something like a mono repo, this is going to be a pain that you feel very, very, very intently. You could end up in a scenario where, I don't know the exact number, but I think the Jira monolith has something like over 1 million tests that run. And so when you want to run those tests, like, that's a lot. It takes a long time, and it really slows down your PR cycle time. So one of the things that the Jira DevOps team is working on inside Atlassian is using dynamic pipelines to implement selected test execution. And they're projecting that this is going to reduce their PR cycle time by 50%. So typically, I'm not just talking the build time by 50%, their whole PR cycle time loop, they're expecting to reduce that by 50% by implementing selected test execution with dynamic pipelines. Another example, which is something that's been built internally, has been built internally and is starting to be adopted, is the idea that we actually don't want teams writing their own pipelines. We actually have teams at Atlassian that are kind of specialized in building best practice CI/CD workflows. And what we want is them building kind of modularized, almost like Lego block type pipelines, and then teams within the business opting into those based on their requirements. So doing things like saying, all right, I've got a Java app, it's using a certain version of Spring Boot. I'm using this test runner, automatically generate me the correct pipeline configuration for this use case. And I want it to A, be best practice, and B, I want it to always be up to date. So if that best practice changes, I don't want to have to go and change my pipeline file. And if I'm that central team, if I change what best practice means, I don't want to have to go and tell 1,000 different teams to update their workflows. I just want to update it in one place in my template library. And then every time that dynamic pipeline runs, we put the new version of that into the pipeline workflow. That's something that we've built as well. We call that managed builds. There's some information already around about managed builds, and we talked about that a bit at Team 24. We're expecting that, which I'm not expecting that, we are already, with this implementation, it reduces the complexity of a large pipeline configuration by 99.7%. Now, 99.7% is kind of hard to actually like grok in your brain what that means. So to give you an example, I want you to look at this. It's sort of like a little block of pipelines logic. And then I want you to look at that. So that in that red box, that's that same block we were just looking at before. And then I want you to look at that. That red box is what we started with. So this is the full configuration that some systems at Atlassian need for their workflow. And to be clear, this is actually not that big. This is about 1,200 lines of YAML. We regularly see customers implementing pipeline workflows that are up around the 3,000 to 4,000 line sort of mark. And we hear about that not just from pipelines, but from lots of other CI/CD tools. It's not that rare to see that. What it looks like, 99.7% reduction, is that to that. That is the entire YAML file for that repository now. And what we do is at runtime, we read through this set of labels, this schema, and we dynamically generate the entire pipeline workflow from that. Because we know, all right, it's a node service, it's using node 20. We have a bunch of rules behind the scenes of what that means, what test runner you want to use, what types of security scans you need to have, how you need to have them all configured, the different configurations for your branch builds versus your testing and staging and deployment builds, all of that stuff. It's all defined in one dynamic pipeline, and teams can change this. This could be, this could be a Java app, it could be a Java library, it could be a Golang service. And depending upon what you declare in here, the dynamic pipeline will go from this to that. So you can see, I hope, how things like this can be massively beneficial for your teams, particularly if you are operating in a slightly more complicated environment, but it's also really useful if you're in a simple environment too. All right, so enough with the slides. Thank you for your patience. Let's get started. All right, let's build something. We're going to build a Forge app and we're going to build a dynamic pipeline app. So let's get started. So the first thing I'm going to do is I have a code directory and I'm going to create a new Forge app. So how I do that. So just a bit of context real quickly. We're assuming that if you're doing this, you've already followed the sort of Forge getting started tutorial, which is available on the Forge developer docs. That will show you how to install the Forge CLI. It will also show you how to get started building a very basic app. And at that point, you're sort of ready to dive into one of these. I do suggest if you're brand new to Forge, complete the Bitbucket Cloud Hello World tutorial before diving into something like a dynamic pipeline or a custom merge check. That will get you familiar with the base Forge app concepts, and then you can start adding on extra things like dynamic pipelines or custom merge checks. If that sounds like a lot to you, I mean this, and I mean this very genuinely, you can be up and running in a few hours. So you can do the getting started, your Hello World tutorial, and be ready to start working on a dynamic pipeline or a custom merge check in a few hours. And I've live coded custom merge checks and dynamic pipelines in 30 minutes on previous webinars. They are very, very, easy to understand and easy to build. So don't feel like this is a big multi-day thing you have to sort of invest in. You can get started in a few hours very, very easily. So the first step is I'm going to go Forge. Great. So we have this lovely little CLI, which basically helps scaffold Forge apps for you. So running Forge create is going to start the scaffolding process. So I'm going to enter a name for your app. We'll call this webinar dynamic pipeline. So the first thing I need to do is select a template. So we have a bunch of templates included in the CLI, and let's hope. I've been having some weird issues with my Node version manager, and so I'm not sure if I'm running the latest version of CLI here. So okay, good. I was hoping this template would be here. So Bitbucket Dynamic Pipelines Provider is the template we want to use. And so what this will do is it will scaffold a dynamic pipeline for you. You'll see here we have other templates here for Bitbucket as well as your Confluence, the other products. There's the Bitbucket merge check one there as well. So you can use that to template out a Bitbucket merge check if you want to. But we're looking at dynamic pipelines today. So enter, it's going to create the app, downloads the template, it sets everything up in the back end and says, all right, your app is ready to work on and deploy. They've set up 3 environments for us, which are now going up the edge of the screen. Production, staging, and development, and then the directory I can change it to. So I'm going to close this real quickly, and I'm going to hop over to my editor and open that new project. And before anyone asks, because we get this question every webinar, I'm using WebStorm. So that is the JetBrains sort of IntelliJ-based JavaScript IDE, product manager. So I only know JavaScript, I don't know anything else. It's a great tool. I recommend it strongly. But if you're using any other IDE like Visual Studio Code or anything like that, this will work just fine. This is just a personal preference of mine, but don't feel like you need to have this particular editor. So this is the app that the Forge CLI has scaffolded for me. So it creates a few things, it creates a package.json. So Forge apps are built in Node.js by default. The Forge runtime or that hosts them is a Node.js runtime. Now, you don't need to use Node.js if you don't want to. You can actually run your own code on your own infrastructure using your own coding language of choice, and that uses Forge Remote. So I'm not going to go for Forge Remote here. We're going to be using the hosted Forge, which is Node.js. I do recommend this personally because it's a really easy system to get set up with, and it's really easy to sort of implement basic logic. But if you really want to use something like Java or Kotlin or Go or whatever else it happens to be, you can do that using Forge Remote and then putting it on your own infrastructure. So what it generates as well is this manifest file. I will chuck the code for this as we go into chat so that you can grab this yourself if you need it. We're obviously going to be publishing the entire repository as well, so stay tuned for that. But we'll sort of make sure we share as we go. So the manifest file is how we tell the Forge runtime what your app does, what it needs to be able to do, and kind of how it works and where it needs to find all the bits and pieces. So the first thing is this app ID down here. Now this will be automatically generated when you do the Forge create command. And then you have this runtime bit down here. This is great. This wasn't here 2 weeks ago, so I'm happy this is here now. So this is setting you to use the new Forge Node.js runtime. If you have an older Forge app that you've been working on by any chance and it doesn't have this, I recommend you go and add this. The new runtime is really, really great, particularly for local development. The local dev loop is genuinely amazing. Like you can be running your Forge app in cloud, testing in the product, and it's like an instant round trip dev loop. You can make a change and it's instantly available in cloud. You can just test it. It's really, really cool. And then up here, this module section is kind of where you actually get into the actual, the logic of your app itself. So I'll go through what this is. So we have here what we've declared what we call a dynamic pipeline provider. So that is your dynamic pipeline app. Now, a single Forge app can actually declare multiple dynamic pipeline providers, and each of them has a key and a name. And then you can reference these in the product when you want to use them. I'll show you what that looks like later. Down here, you also have this function. Now, functions are used for a lot of different things. And so most modules you'll see will all reference a function. So you see here that has a key of main, and up here we're saying function main. What we're saying is this dynamic pipeline provider is implemented via this function. And this function is found in index.main. So if I go to source and index, you'll see here there is a main function, which is being exported. And that's what we're referring to here. So just to kind of give you the kind of high level topology of how that sort of thing hangs together, functions are referenced by handlers, which are just the file path and then the function name. They have a key, and then your module references the function you want to use. The name and description are whatever you want them to be. The key is whatever you want it to be, but it does have to be unique. So just keep that in mind. I also strongly recommend making the name unique as well, because the name will show up in the UI, and you don't want to have multiple dynamic pipelines with the same name. It will get very confusing. Ask me how I know. All right, so whenever you're building a Forge app, one of the first things I always recommend doing is kind of sketching out what you want the app to do at a high level. And then from there, implementing the logic you want to have. But it's good to have a bit of a design up front so that you know where you're going to go. So I'm going to go to index.js, and I'll show you this real quickly. This is what the Forge CLI scaffolds. And now what this basically is just doing is a request comes in. We log that request as a nice, pretty printed JSON, and then we just return the pipeline's configuration property from that request back to the product. What that will do in practice is basically it will just run the exact pipeline that was sent to it. So you don't have to make changes as part of a dynamic pipeline. You can just return straight away. And what it will do, if you return the same thing, is just run what was coming from your YAML file. What we want to do real quickly is scaffold the design we want to do. And then I'm going to test this and show you that it works. And then we'll sort of work on it. Actually, I might test this first and show you how this works. So what I'm going to do, this is all set up. So I'm going to go Forge deploy, which is going to deploy this app to the Forge platform. You'll see there's a linter built in, which is going to do some linting of the app. And then once that's done, it will deploy. 2 moments. So no issues found, deploying. So it packages it up, it ships it up to our platform. So if you're not familiar with Forge, we do all of the hosting, we do all the management. You don't have to think about it. You literally run Forge deploy, it gets deployed to our infrastructure inside the Atlassian Cloud Platform. So we look after all of the security elements of it as well. Forge apps cannot access anything outside of the Atlassian network unless they are explicitly declared in the manifest file. And those external sort of resources they call need to be approved by your workspace administrator. So Forge apps have been built with a really, really, really heavy focus on security. So we strongly recommend that you do use the Forge hosting platform because we look after all that for you. We also look after a lot of things that sort of baked in for free as part of the Forge engine. The best one, the most exciting one, in my opinion, is auth. You don't have to think about auth. You don't have to manage auth clients or auth secrets or tokens or any of this kind of stuff. You literally just call one function and we do all the authentication for you. You can call into the Bitbucket APIs kind of as if you were kind of part of the Bitbucket product itself. All right, so that's deployed. Now I need to install this into my workspace. Forge, install. So that's going to now ask me where I want to install it. I want to go Bitbucket. Need to get the workspace URL. Give me 2 seconds to grab that. So the workspace URL context is everything up to the second / in the URL path your Bitbucket workspace. So for me, that is bitbucket.org/forge test. Don't go anything past that first bit. So that's your workspace name, because otherwise you start getting into projects and repos and it won't like it. It's going to ask me if it's happy for me to install. This app doesn't use any permissions at the moment, but we will add some permissions to it later. I'm going to say yes. It's going to install it. Now I can do this because I'm an administrator of that workspace. If I wasn't an administrator of that workspace, I would not be able to install it. You would need an admin of the workspace to do the installation for you. All right, so that is now live. So let me just hop over to my browser super quickly, and we will show you that. Go. So we're now over in browser. You go into repository. I'm going to open this up real quickly. So this is the YAML. This is the pipeline file that's implemented in that repository as YAML. So you can see here, it's just a basic pipeline. It has one step. It just says hello from the hard-coded pipeline. Nothing intelligent, nothing smart. And I'm going to go to repository settings, down to dynamic pipelines, and you'll see here repository dynamic pipeline provider. That webinar dynamic pipeline, which if I go show you right now in my manifest, that's the name I gave to the dynamic pipeline provider. You'll just have to trust me on that. I go save, and that's now saved. So what that's going to do now is anytime I run a pipeline in this repository, it's going to execute the dynamic pipeline, and it will use that to modify the pipeline configuration. Now, because I haven't modified it as part of my logic yet, it won't modify it, but it will log the full configuration. And I'll show you that in 2 seconds. Hop back to my editor. So I'm just going to run a pipeline real quick over here. And you should. Now, what I'm going to do before I do that, sorry, is I'm going to go down to my terminal again, and I'm going to go forge tunnel, another forge command. So forge tunnel is how you do your local development loop. So forge tunnel basically will run the function you're working on locally in the cloud. It will intercept any requests going to that function from the cloud workspace, and then pull all the logs for that in real time down to your local machine. So this is really, really cool, in my opinion, because you're not running it locally, you're actually running it in the cloud platform. And so you can be interacting with it in the real live environment, and you're getting all of those logs here, debugging it in real time. And then any code change you make is instantly replicated up to the cloud, and you can get that feedback effectively real time. It's really, really nice. In my opinion, again, biased, it is one of the nicest like functions as a service local dev loops of any provider. And I'm talking including like dedicated functions as a service providers. It's a really nice loop. So I'm going to go to the pipelines page now. I'm going to go here, and I'm going to get it to run a pipeline. Oh, look, some logs. So if I scroll up, yeah, handling dynamic pipeline request, which is what we logged here. And then we see this lovely sort of pretty printed blob, which is the actual request that came from the dynamic pipeline, came to the dynamic pipeline from Bitbucket Cloud. And you can see a bunch of stuff in here. So there's a commit hash that's being related to. This target is how we determine which pipeline's being run. There's a pipeline configuration. There's the image it's going to use. Now, there's a lot in here, and to be clear, you don't need to understand all of this right now. We will be very soon publishing things like TypeScript library, which will have typings for all of this stuff, so you'll get autocomplete. It'll make it all just much easier to work with. As well, though, all the explanation for everything in this configuration is on the documentation reference site. So you can go in and you can go through the whole sort of object, the configuration object, what every single property means, what they can be changed to, if they have validation, what kind of validation they have. Obviously, it's too much for me to go through right now, but just note that is all available. And there are some other utilities going to be coming soon, like TypeScript libraries, to help you work with this just much easier. And then down below, we have some just context information. So who the creator of the pipeline was. This is like a user ID, the repository ID, the workspace ID, some other context. Stuff that you don't need to worry about right now. Once you get more into it and you get more advanced, you understand what's going on, that stuff will become more relevant. The main thing is you can see here, it runs when I run a pipeline and it logs all this stuff here. Great, so that works. So let's sketch out what we actually want to do. So we want to implement some logic to make sure that every pipeline that runs in our workspace is running a secret scan. We don't want any code being merged into our repositories that have secrets in the code. How do we want to do that? So first thing is we want to get the pipeline it's about to run. Now that's done for us automatically, so that's great. Next thing we want to do is we want to sort of inspect the pipeline, check if the pipeline that will run already includes a secret scan. Because if the team that's implementing it has already included a secret scan, you don't want to add another one because that's just going to add more time to the build and going to annoy people. So you only want to do it if they haven't already got one in there. So we need to do some inspection. If they don't, we want to add one. And if they do, we want to run what they have configured. So that's the kind of high level sketch for what we want to do with this app. So let's start implementing that. So the first step then, we already have the pipeline configuration coming in, is we want to look at that pipeline configuration and see if they already have a secret scan being run inside it. So I'm going to get rid of that log. I'm going to create some space. I'm going to install a couple of libraries really quickly that come from, so one from Forge team itself, and one just makes my life a little bit easier. So I'm going to npm install at forge/API. And then I'm going to install that. So this is the helper library that the Forge team provides to let you interact with the API. Thinking about it in my head, I actually don't know if I use this or if I just assume I need this, but it's always good to have this installed because it has a million use cases and it's very useful. This is what lets you interact with the API without having to do any kind of authentication or anything. We handle all that for you. And then what I'm going to do is install npm install -d prettier, because I'm lazy and I don't like formatting my own code. So I'm going to install something to do that for me. If you are new to the JavaScript / Node.js ecosystem, install prettier, set it up in your IDE. It will make you very happy. And I'm going to quickly configure this, because this is great for webinars, particularly because it means all the code you see looks nice and pretty and is correctly formatted. There we go. So for context, what pretty does is it just automatically formats your code to look really nice, because I can't be bothered doing it myself. And make sure you never forget a semicolon, which is always good. All right, so let's start building this out. So the first thing I want to do, you remember from that big object we had before, can't scroll, okay, no, there we go. There's a lot in here, and we don't want all of this, actually. We only want certain parts of it. Specifically, we want to get the pipeline configurations that are actually running, which is this section here. You'll notice there's only one pipeline in this section. That's because I had a very simple YAML configuration. You could have more of these in here. So we want to cut those out so we can have a look at them. So I've got some code here. I'm going to just copy across. I'm not going to be writing this all in real time because I will be here all day. So this grabs the pipelines configuration out of the request object. And then this gets the actual pipelines array from that object again. So you see here down in the terminal, it's a pipelines object. There's a pipelines object, and in that there's a series of different pipelines. The main one is called default, but there'll be others. And if you look at what the pipeline actually is, it's actually just a list of smaller objects. And each of those objects is a step. So pipelines are made of steps, and a pipeline is not actually a sort of a thing itself. It's just a list of steps in a particular order. So when we say pipelines, this is now just an object with a list of steps inside it. And then what we want to do is we're going to say, we want to iterate over each pipeline that has come in. Now, in this case, it's only one, but there could be more. And so we're going to iterate over that list, that object of pipelines. We're going to get the actual pipeline each iteration. And then we want to check if the pipeline has a get secret scan in it. And then if it doesn't, we're going to add a secret scan. Now to do that, I'm going to create some separate functions that can do that sort of checking for me. Now, I'm not going to, again, handwrite all of this stuff because a lot of it is pretty kind of basic boilerplate. It's me just kind of like looping over some stuff and looking for a string and things like that. So I'm going to copy and paste it in, and then I'm going to walk through it and explain to you what it all does. I'm going to move this over here. Grab this. This pipeline includes pipe function, which I created. I'm going to go here, and we'll go great. What are you complaining about? What was the other argument you expected? Oh, I need to tell the name of the pipeline. Name of the pipeline we want to look for is Atlassian get secret scan. So this particular function is used nice and flexible. So I can pass in the name of any pipe I want to check for, and it will go and look. For those of you who don't know, I keep talking about pipes. Pipes are pre-built blocks of functionality we have for Bitbucket Pipelines that implement pre-baked features. So for example, we have about 100 of these things. One of them is a get secret scan, which basically will scan over your code in the repository and basically raise an alert if there are secrets stored in that code and prevent you from merging that code into your repository. So when I say a pipe, that's what I mean. So this function is designed to look through the pipeline and see if we include that pipe. Let's see how that actually works. So I'm going to go just another bit. So when you access this repository that we're going to share, all of the code is all commented up so you know exactly what it's doing. So I'll just walk through it now relatively quickly. So like I said before, a pipeline is just a list of step objects. So all we're going to do is we're going to loop over the pipeline and basically say, do any of the steps in this pipeline include the pipe that we passed in? And that pipe is just a string, the name, we just pass it down. If you're not familiar with Node.js, .sum is basically just the equivalent of loop over all these things and tell me if one thing in the list meets the condition that I'm specifying. So does one thing in the list of steps include the get secret scan pipe? I drop down into this step includes pipe. So what this does is it opens up the actual the pipeline step. And inside the pipeline step, there is some properties called scripts, which is basically the actual logic we execute. What that would look like in a YAML file is a series of bash scripts that are being executed. But it can also be where you declare a pipe that you want to run. So what we're going to do is we're going to get scripts from the step, and then we're going to basically ask if those scripts include the pipe that we're looking for. Again, this is all kind of like simple, but also a little bit kind of like, boilerplatey. So I'm kind of not going to go into huge detail about it. So back down here, we have a series of scripts that are from the pipe. One of those might contain the pipe that we're looking for. And so we do the same thing as before. We ask, do any of the scripts in that list include a pipe? And does the pipe name include the string that we passed in, which up the top was Atlassian/getSecretScan. We're using includes here rather than equals because pipes are versioned. And I don't want to necessarily make sure they're using the latest version of the pipe. I just want to make sure they're using the pipe somewhere. So I'm leaving the version number off the string that I put in up above, and basically just saying, do they have a pipe that includes the base part of it? And then the version can kind of be whatever that I want it to be. If I wanted to, I could specify the version number. If I wanted to, I could update this function to do some kind of like, regex matching or glob string matching. So I'm like, I only want to accept it if it's version 2.x or something like that. You can literally do whatever you want. That's the nice thing about this just being code that you can change as well to do whatever you would like it to do. So back up the top, we've sort of walked through how these work. So what we're going to say is for each pipeline in the request, check if it includes the getSecretScan. And then we're going to say, rather than just doing that, we're going to say, if it does not include this, we want to do something. If it doesn't include the getSecretScan, we want to add the getSecretScan to it. So what that looks like is this. So I have created this little add getSecretScan function, which you pass the pipeline into. Now, this is basically just like a template that I've created real quickly. So this is the structure of a pipeline step. So I basically scaffolded out a step that includes the getSecretScan pipe and some configuration. And what I'm going to do is I'm going to say, well, if I don't have the secret scan anywhere in my pipeline, I want to get this step that I've predefined, and I want to inject it at the beginning of the pipeline. So I want it to be the first thing that runs. So I've created this as an object. It's relatively simple. Again, we'll be sharing TypeScript types for all of this stuff. All of this is documented on the documentation site. I'm basically saying take a pipeline in, and then all I want to do is pipeline.unshift. Again, you're not familiar with Node. Unshift is just the equivalent of like adding something at the end, but at the beginning. So it's like add that object at the beginning of the pipeline array. So what that will basically say is this will now be the first step in the pipeline workflow, because all the pipeline workflow is just a list of steps. And then we're done. That's all we need to do. You don't need to do anything else. So we're basically saying, get this, add it to the beginning of the pipeline, but only do it if it doesn't already contain the secret scan. Now, one thing you could do here to make this more flexible is rather than making this be like a strict add secret scan function, you could make this a bit more generic and be like, add a pipe. And it could be any pipe. And what you could do is you could have a series of these kind of like pre-built in just like in a map. And you could map them by key, and you could say, all right, I'm going to pass in the pipeline, and I'm going to pass in the key of the pipe I want to add, and then have a look, just look up that object and sort of inject it in there. So this is a really simple example, but you can make this much more powerful. And this is sort of almost like the start of getting into that managed builds territory, step 1 of 100. But this is kind of how you go down that path to starting to build out things that are much more templated. And then what you can also do, because this is all just Node.js, is you can bake these things into an NPM package. You could share it amongst different pipelines. You can share logic. It gets really, really powerful. All right. So I'm going to quickly just add this here. I'm going to say, what do they call it? Add getSecretScan. And I'm going to pass the pipeline in. Great. So just to review real quickly, we're going to say, get the pipeline configuration, extract the actual pipeline's objects from it, iterate over each pipeline, see if it includes the secret scan pipe, and if it doesn't, add the getSecretScan pipe as the first step in that pipeline. And then we are going to just return this. Now, some of you may be wondering if this is going to work because I'm not actually redeclaring anything back into this here. It will work just because it's Node. Object and array relationships are referenced, not based on value. So this will work because all the way up here, I'm referencing something from this request object. So I can just make changes to it and return it, and it will work. I'll show you in a second. You could, if you wanted to, do this explicitly by basically creating like a new pipeline object and then reconstructing a new pipeline configuration. It's just a bit more code, and this is just a bit more neat and tidy, but you can do whatever you want, it's fine. And if what I just said made absolutely no sense to you, don't worry. You don't need to understand it. It's just some people might be wondering. All right, so we're good. Now, our forge channel is still running, and because it detects any changes we make here, it's ready for us to test. So I'm going to stop my share, go back to my browser, go to Zoom. So back here, back in the repository, if I go to my repo settings, I can see here that this is still configured. Great. Now, remember last time it didn't do anything. So if I go to the pipeline and I show you the pipeline, it didn't run, sorry. It just would have printed something saying hi from the dynamic pipeline. So if I now go to here, and I'm just gonna, what I'm gonna do is, we're just gonna add a README file or something like that. I'm gonna create a pull request. This will run a pipeline.
At this point, we had some issues with the live demo, but we got the pipeline to work, and you can see that 1 hour into this video. I'll create a chapter so that you can click there directly. I can also guarantee that the repository linked in the video description works, so go and try it out.
Katarina, are you able to have a look at the questions?
So I think the first one is regarding dynamic pipelines, can it reach out multiple times and not just initially? I'm thinking about depending on the result of tests. More tests might be needed to execute, hence another pipeline plan would need to be returned.
Yeah, really, really excellent question. So as of today, the answer to that is no. That being said, it is something that we're looking into enabling. What we are thinking though is getting the design right for that is you have to be careful, basically, because there is a risk there where you end up in these kind of like infinite loop scenarios, because you kind of like just keep calling back to them again and again and again. So one thing that we're looking at, and to be clear, we're not sort of committing to doing that right now, is the idea of kind of like what we call parent-child pipelines. And you would be able to basically call another pipeline from the sort of parent. And when you do that, that child pipeline would be able to invoke another dynamic pipeline. So you could sort of get to a certain point, get to a step, and then basically say, all right, I want to execute a child pipeline, and then that could be dynamically generated. Doing it that way provides some more guardrails around it, so you don't have this risk of kind of just like this never-ending pipeline because you keep looping back and generating the next step. But does give you that ability to kind of look at the result from previous step or previous set of steps and then use that to generate the next step. So that's one way we're looking at achieving that kind of flexibility. Either way, we're definitely looking at providing the ability to kind of provide like kind of recursive generation. We're just going to make sure that the way that that is done is kind of safe and doesn't set you up to create these kind of like horrendous infinite loops of things.
Ready for the next one?
Yep.
How do dynamic pipelines handle stages or steps that require manual deployments?
Exactly the same way as a normal pipeline does. So the dynamic pipeline itself, if you think about it, doesn't actually change the way pipeline works. It's more just like it's a template. It's a configuration generator. So it doesn't really affect the way things like manual steps work. You can generate a pipeline from a dynamic pipeline with a manual step in it, and that manual step will still need to be implemented by a user when it is returned. So all of that functionality that exists there today works exactly the same way it does before. It's just a matter of generating it. So we have teams today already doing that. They generate steps and stages with manual steps. Now, today, manual triggers aren't supported in stages, but that is coming very soon. So I'm not sure if your question was specifically about stages because that isn't there today. But if you have manual steps in your pipeline today, that will all work the same way it would have before.
Cool. Is there a way to allow a step to fail without breaking the pipeline? I've seen a lot of people overriding the exit code instead, like so, and that there is a mypy pipe through.
Right. Yeah. Sure. So the answer today, no. The answer very soon, yeah. So we're looking at implementing what we call failure strategies, which basically would let you configure what you want to do on failure, and that one of the options there will be to kind of skip the failure step, so you better keep going.
Cool. So can parallel steps have nested parallel steps in the dynamically generated pipelines?
So this is an interesting one. All of the existing constraints that apply to pipelines still apply to dynamically generated pipelines. You know, something very, very careful with my wording here. So what that means is that constraint still exists, but because it's dynamically generated, it does give you the ability to do some interesting things. For example, dynamically generate a lot of parallel steps within a stage. A lot of steps within stages. So yeah, it's a tough question. Yes, the constraints still exist, but because you can do things with code, you can get a lot more out of it because you don't have to write everything by hand. And we will be looking to add more flexibility to this over time. But all those same restrictions that apply for hand-coded pipelines still apply for dynamically generated ones. The dynamic generation just gives you the ability to do kind of more complicated things that maybe you wouldn't have been able to do before, or would have been very laborious to do before.
Using dynamic pipelines, can user trigger another repository's pipeline?
Yes. So I guess I need to understand what exactly we're talking about. So are we talking about from the dynamic pipeline app itself directly, or are we talking about can it generate a pipeline that will trigger another repos pipeline? The answer to both is yes, you can do both. So there you can call the pipelines API either from the dynamic pipeline app, which would then be able to trigger a pipeline, or you could implement logic inside the generated pipeline, which would do that. And that's one way you can kind of have, let's call it very janky sort of parent-child pipelines. Again, we're looking to add more functionality to do that kind of like natively in the future soon. So yes is the answer to the question. There's a few ways you can do it depending on what exactly your question is as to whether you mean from the dynamic pipeline app or whether you mean from the pipeline that it generates, but you can trigger those from both. It's easy to do it from the dynamic pipeline app because you have access to the Forge API auth functionality kind of for free. So you can just call the API, the Bitbucket pipeline API, tell it what pipeline you want to run in the repo and it will run. You can't create arbitrary pipelines. They have to be declared in the YAML file already. Something that we are considering as well in the future is actually just adding an API which lets you send the JSON structure of an arbitrary pipeline at an endpoint and run that even if it doesn't exist in the YAML file. So that is something as well that we're looking at potentially doing, which would help that use case as well.
Cool. How does it work with on-prem runners? Can we use an internal NPM repositories to store the NPM packages and import them when running from on-prem runners?
That is a really excellent question. So that's actually more of a Forge question, to be totally honest, than a Bitbucket question. So the question is around, can you use a private NPM registry with Forge apps? So speaking as from Pipeline's perspective, the way you would do that, and I don't know if Forge natively supports that. So I will assume it doesn't and tell you the workaround from Pipeline's angle, and then we can probably follow up and see if it does. And then if it does, it's a much simpler conversation. So the way you would do that is you would probably want to actually deploy your Forge app from a pipeline. And so you would build your Forge app using your private NPM packages. You would then run a build in pipelines with assuming pipelines is configured to talk to your private NPM registry. And then you would pull those in as part of that. And then you would bundle that app. So you'd basically bundle it down so that you're no longer using the code being pulled from that package. You're sort of pulling all that out and you're packaging it all into a single file, single like index.js. And then you're deploying that single index.js to Forge. So that way, Forge isn't having to access your private NPM registry directly, but you're still able to access the code that's in that registry and then you sort of do that translation at build time. That would be the way I'd recommend to do it today. I don't think Forge supports pulling from private NPM registries directly. So the way you would get around that is you'd pull from that registry during build, you would then bundle the code, and then you would deploy the bundled code.
Cool. You mentioned reasons why you decided to go the programmatic generative way of creating a dynamic pipeline. In my experience, building DSLs, one of the properties are that they provide a better debugging experience. How can one see the decision the Forge app has taken in a specific pipeline run for auditing purposes?
Yes, that is a really excellent question, and it is one that we did think quite a bit about. So I'm going to go to one of these runs from 13 hours ago that did work, which was me testing it last night. I don't know what's happened since today. So that's saying failure to invoke domain pipelines because the current domain pipeline was broken. Good job, me. And so what we do when we execute the dynamic pipeline, we actually store the generated configuration that is executed for the pipeline run. And we actually store it in our database because we know that it's really important for you to be able to have visibility of what was actually run in your system so that you can see exactly what happened and also so you can debug it. In the pipeline details view, which is not loading because of the broken dynamic pipeline, sorry about that. I can say here it says this pipeline is generated by dynamic pipelines, view the configuration. I click that and it loads up this view. And what it does is we get back that JSONified pipeline workflow that was generated. And then we translate that back into its YAML form. And then we store that. And then we make this available for you to view in the product as a YAML. The reason we put this in here as YAML is because as a human, this is how you're used to seeing Bitbucket Pipelines configurations is as YAML. So we translate it all back to YAML, and then you can see it here, and we store this against this pipeline. So you can see exactly what was actually executed in the workflow and how it was structured. So this is how you would sort of debug it. And we added this in here exactly for that debugging use case, so you can see exactly what was run. This will happen both for the repo and the workspace level ones. We only store the final output though. So if you have a repo one and then a workspace one, we store the one that comes from the workspace rather than the repository one because that's the actual final one there.
So the other question is about performance of the build pipelines in comparison to dynamic pipelines. And thank you, Alex, for already providing some insights on that.
So again, I'll go back to the previous point that I made in terms of like the dynamic pipeline doesn't actually change the pipeline itself. It changes the generation of the pipeline configuration. So the performance of the pipeline is exactly what it would have been if you had handwritten that pipeline configuration. The process of generating the pipeline itself we're talking a couple of seconds usually. Like we see round trip invocation times of I think 1.8, 1.9 seconds on average. Now, where it may get a little bit longer than that is in situations where you're calling out to third-party systems or other systems. So you've just got to factor in your latency there. So any additional latency you add to those calls is going to add to the time it takes for the dynamic pipeline function to execute, which will add on to the overall build time. But the actual builds itself take the same amount of time. And in, I want to say a month or so, they'll be going much faster because we'll be shipping a new pipelines container runtime, which is going to enable you to add more CPU and more memory to your builds as well, which will make those run even faster. Subtle plug.
And then we have a question about versioning the Forge functions. So the question is specifically if we can do it in a way similar to the pipes, so that we can introduce changes in a non-breaking way.
Yeah, so the answer is yes. I'm going to be honest, maybe Katerina or Ian, you guys might be better placed to answer that because that's more of just a generic Forge question. Either of you want to have a go?
So what can I say about this? So yes, so I think in general, like we suggest testing. So in Forge has 3 environments by default. So it provides a developer staging and a production environment. So that can be used for testing the different version of the functions. And yeah.
And I think it also the Forge platform does version your apps as well. So every time you do a deployment, it will automatically version your app. And I assume it just follows like a semantic versioning structure. I don't know how you would declare like a major upgrade, but we have to do that because whenever you do a major upgrade of your app, we actually need to ask the administrators of the workspaces if they're happy for the new version to be installed, because that new version may require elevated privileges over the old one that they didn't previously approve. So the versioning is all done automatically inside the system. If that answers your question. So real quickly, because I gave up. I must have put a semicolon wrong somewhere. I don't know what's happening for. So I'm going to show you one I prepared earlier, which does work. So I'm going to run pipeline. I'm going to go up here, select the main branch. It has now generated me a list of pipelines from the dynamic pipeline app. Default, I'm going to run that. So this is literally the exact same code. I don't know why the other one wasn't working. It's going to be 100% user error. I did something wrong. I'll find out later on. How you know it's a real live webinar. Anyway, this is now working. You can see our lovely little scan for secrets step has been added into the pipeline, like it should have been before. It's now going to run a get secret scan over this repository. And then you see the hard-coded step is here, second in the list, which is the one that was actually sitting in the YAML file. So it does work, promise. I wasn't lying. I just screwed up the code somewhere. Real quickly, I'm going to leave that now. So that's currently configured in the repository. I'm going to turn off the repository level dynamic pipeline. I'm going to go to the workspace settings. Go down to dynamic pipelines in the workspace settings. And I'm going to, oh, it was already there. Interesting. I wonder if that was why I wasn't working. That's now configured at the workspace level. And I will go back to my repository. So I've now turned it off at the repo level, just to be clear. It's on at the workspace level. I'm going to run it again. Two secs, Docker containers, and there's your get secret scan. So even though this is turned off at the repo level, it's still applying that to this pipeline because I've configured it at the workspace level, which is then rolling it out to every repo in that workspace. And also you'll notice that this page loaded basically instantly. The time it took for this page to load was the time it took for us to call the dynamic pipeline and actually execute all that stuff. So it adds no time at all. So it does all work. And I can know I'm no longer distracted by trying to fix the code. I can actually look at the Q&A properly now. Thank you for humoring me on that. So how to get the PR status? Is that the next? Oh, sorry, I'm looking at most recent upvotes. See, this is why Katerina was running the Q&A. You're better at this than I am.
No, I just have to remind you every time to go by most upvoted.
I reminded myself that time, to be fair. All right, I love the idea of build engineering as code. Thank you. That's I like that. That's actually really cool. For use in a regulated industry, we would need visibility and auditability. Could you please speak to commits and change permissions? Commits and change permissions to the Forge function code itself. Ease of reading if someone starts at a Jira story, clicks through to a PR, and to recording of a build and deployment. Yeah, absolutely. So one of the things that we kind of kept really, really top of mind when we were designing the system was we didn't want to change the core workflow in any huge way. We wanted this to be entirely additive. So any compliance controls you have today that are based off the outputs of a pipeline, for example, are absolutely still valid in a dynamic pipeline world, because all we do is just change the configuration. So what you see on the pipeline details page, what you say pull from the pipeline's API, any of that stuff is still the kind of canonical source of truth. We just change the configuration. Now, what that does mean is that it is possible for there to be a delta between the YAML file stored in your repository and what actually gets run in the pipeline. And that could be a challenge from a compliance perspective, an audit perspective, which is why we store the final output of the YAML as well. So the actual configuration which is executed, and you can access that and store it yourself. As well as a general rule, we would always suggest having your Forge apps themselves in your Bitbucket in a Bitbucket repository, and for every change to them being audited itself via pull request, so that you can see every change happening to the dynamic pipeline app, in addition to every change that every pipeline that it generates. So the main way for me to answer this is there is auditability baked into the system all the way through. For example, that was a critical requirement that we had internally. This is being used by internal teams that have to be able to do things for like FedRAMP and all that kind of stuff. So we need auditability all the way through. So we can track it everywhere, and so can you. The main thing is to just add one extra step, which is that kind of like the dynamically generated output, which is stored, and you can access that and audit that dynamic output as well. That dynamic output is immutable, and that is like exactly what was executed. So you can treat that the same way you would treat the version controlled YAML in the repository itself. Cool. How about enforcing signed commits? Is it something in the roadmap, or can it be implemented by don't check? So signed commits is something that's coming natively. I'm not going to go into huge detail because it's not really related to this topic. It is on the roadmap. It's not something my teams are working on, so I can't speak in detail about it, but just that it is absolutely on the plan, and that will just be native functionality as part of the product. Is this functionality entirely dependent on NPM and Node toolchain? No. Is there any way to use some what I would consider more common DevOps tooling languages, e.g. Python, Go, Bash, barring that is TypeScript a possibility? Other types available? So the answer to that question is yes to all of the above. So you can use whatever you want. The Forge runtime supports Node.js natively. So if you want to run it in the Forge cloud platform, that's all in Node. So you can also write it in TypeScript and then compile it to Node. We are working on TypeScript type definitions. They're about halfway done. So they'll be out in the next few weeks. That being said, you can also just do this with your own language of choice. The only thing there is that you need to use Forge Remote. So if you look up Forge Remote, that basically means that rather than calling a function that's hosted in Forge storage for the dynamic pipeline, which I will show you what I mean here, if I go to manifest, rather than calling this, you actually would declare something that looks like a URL path here, and that would point at a service that you are running yourself that you could be writing in whatever language you want, Go, Java, Python, whatever you want to do. And then so pipelines will call out to that URL at runtime rather than to the function stored in the Forge platform. And then you can make the same modifications and return the configuration back to us, and away you go. So it's not restricted to Node in any way. Node is just what's supported by the Forge platform runtime. You can run your own code on your own system, and you just would do that using Forge Remote. I'm not going to go into Forge Remote here because it's quite a deep topic. It's very easy to use. It's as simple as kind of like changing this manifest a bit and declaring a URL path that you want to call. Can the dynamic pipelines be tested locally on your machine? This has been our biggest issue with our builds, is that YAML cannot be run locally. To address this, we use reusable shared build scripts that can be run locally and can be called directly by Bitbucket YAML. You might just answer my question. So it's a really excellent question, actually. So it depends on what you mean by tested. This is one thing I love about dynamic pipelines, and one of the things I really wanted to achieve with it. And I'm really excited because we're almost there. Two things I wanted to be able to achieve with dynamic pipelines. One, I wanted people to be able to write unit tests for their pipelines. For some of you, that sounds probably really cool. For some of you, that probably sounds like just really, really hardcore nerdy. I really was excited about the idea of people being able to write unit tests for pipelines, because that is a really powerful capability. And similarly, once we add the TypeScript typings which are coming, I want people to be able to have type-safe pipelines so that you're not dependent on knowing sort of particular string structures and things like that. You actually get type safety, and you can run the TypeScript compiler over your dynamically generated pipeline at runtime and do type checking on it. So both of those are absolutely possible because, again, it depends on how you do it. If you're using Node.js and in the Forge runtime, you would just use sort of a standard Node unit testing library like Jest or vtest or something like that. And then similarly, if you're using TypeScript, the TypeScript compiler will give you all the type safety benefits. If you're building it with something like Python or Java, you would use the testing library of your choice. So you can absolutely write unit tests for all of these things. You can also do integration testing, but that gets probably a bit more complicated because you kind of end up in a bit of a weird recursion of like you could be doing integration testing from a pipeline, which is running another pipeline, which is generated dynamically. And it's possible. It would just get a bit mind-bending of the nested layers of pipelines calling each other, but it's absolutely doable. The simplest way, though, is doing unit testing of the logic locally on your machine. And then in that context, you just have to kind of make sure that the kind of template blocks that you write are valid. And that's where the TypeScript typings will come in handy because they'll be able to validate those for you as well. Question for cloud, how to get PR status, whether it's ready to be merged, example with API v2, such status API was deprecated, and now I can't find a way to retrieve status of the PR. I want to trigger tests only if PR is ready to be merged and passed all checks like approved and buildable. Yeah, great question, Bogdan, and sorry if I pronounced your name incorrectly. Let me follow up on that. I'm very confident it is available. I know that the statuses for custom merge checks, which we shipped about 2 weeks ago, currently not available via the API. That's something that we're looking at adding. I don't know about the basic one. I will talk to the team about adding just a basic kind of top level property on the PR of like merge status or something like that, which will just encapsulate all of that stuff together. And then we can access that relatively easily. It's probably easier just to add one top level field rather than exposing a million other lower level APIs. And that way you can just call that and access it. So I don't know the answer today. I'll look it up and I'll share I'll share that in the community group. I'll also talk to the team about making sure that if that isn't available, we add that in so that you can access it because that is something that should be able to access, particularly for this kind of use case. I would assume the YAML is still validated based on current. Yeah, really excellent question. I should have touched on that. Yes, 2 times. So we validate the YAML coming out of the repository itself when we're parsing it before we send it to the dynamic pipeline. And then we validate it all again when it comes back from the dynamic pipeline. So if the dynamic pipeline returns invalid YAML, we will not execute the pipeline. And we do that for each step. So if you run a repo one and then a workspace one, we validate it at each pass. And if it's returning invalid, I'm not going to say invalid YAML because it's not YAML at that point. If it's returning an invalid configuration, we won't continue to the next stage in the chain, and we'll raise like an error basically in the product to say that it was not valid. So yes, it's validated on each pass basically. They do not have a dynamic pipeline in Bitbucket Pipelines YAML like pull request. Will dynamic pipeline trigger when a pull request is opened? Yes. So you don't need to put anything in the YAML to get a dynamic pipeline. And thank you, Alex. You're absolutely right. So if you configure it in the repo settings, it will run across every pipeline in that repository. And you can target specific branches in your code. I didn't go into that today, but you can do that. And then similarly, if you declare it at the workspace level, it will run across every repo in the workspace. Again, you can target specific branch patterns in the configuration. So you don't need to have anything in the YAML to do that. And that was by design because we wanted people to be able to keep the YAML exactly the way it is today and have this as a layer over the top. It seems like something we do today. We have steps that generate or manipulate the pipeline, usually using private pipes, and we can use whatever language we want to do this. What would you point at as the advantage of this over that approach? So Kevin, great question. A bunch of things, to be honest. One is speed. So yeah, you can do some of this with pipes and stuff. It's not a very user-friendly way of doing it. So when we were designing this, we looked at some solutions that other providers do. And being an Australian company, we looked at BuildKite. If anyone's familiar with them, they have a dynamic pipeline concept. We looked at a bunch of other providers as well. One of the things we really didn't want to do was this idea of a pipeline kind of spitting out other pipelines, or a pipeline that spits out steps of a pipeline, because it's very unstructured. And at the end of the day, it's almost like you're just kind of doing string manipulation, and it can get really messy really quickly. We wanted to do something that was more structured. We also wanted to do something that was hierarchical. It could be baked into the workspace repo and soon project hierarchy. We also want something faster. So the approach you're going with absolutely is viable, and you know, there are a few customers who do that today. And congratulations on getting that to work, because that's actually quite complicated. Dynamic pipelines are much simpler. It's the first step. They're much faster to run. It's 1 or 2 seconds to get the configuration you want, rather than sometimes minutes, depending on how many different pipes you're running and things like that. They have auth baked in, so you can call back to the Bitbucket API or any other products API. They've got auth. You can also call out to other systems really easily. You can do that from pipes, but it's a bit complicated. You get the workspace hierarchy component, which you don't get from the solution you guys are talking about today. And that's something that pipes kind of based solution simply can't do. You also, even the repository level kind of orchestration, you would struggle with. So this is not dependent on your pipeline YAML file having any particular configuration in it. So if you have a team which is trying to set standards or policies at the company level, you're no longer dependent on all of the teams around the business implementing the standards or those policies that you define. You could now inject those using a dynamic pipeline. So it will solve a lot of the same problems, but I would say in probably an order of magnitude less work. Now, whether you want to go and refactor all the stuff we've already done to use this is completely up to you. One benefit is that you will get much faster build times, because you're not having to run all those pipes to generate the other steps, depending on how you do that. I'm sure if you do that as a build time step, as in like you build pipelines from pipes, in which case you're not having to do that all the time. I presume that's what you're doing. So in that case, if you're using a pipeline to generate up another pipeline file, one of the other things you get from this is it's up to date every invocation of the pipeline, not just at the last time you generated the pipeline. So there's a bunch of benefits. It is designed to solve a similar type of problem, just more holistically, by also doing it at the workspace level, and also just in a way which is a lot easier to work with, to be honest. Does pipeline generation time count against build minutes? No, it does not. So for starters, it's like a second or two, but even then, no, we do not count that as part of your build minute generation. And going back to Kevin's point, you do technically pay for the time the pipeline is running to generate the pipes. Whereas if you're doing it in dynamic pipelines, we don't charge you for that. Now, I want to be clear, the Forge runtime today, there is no price associated with it. And I don't know if there's any plans for that to change. But you are running in that system. There are rate limits attached to that, which you should be aware of. They're very generous rate limits. So just be aware of that. Don't go executing more than a few million invocations in a week, please, for any reason. As a follow-up question regarding debugging of the dynamic pipeline, if my Forge app has if then else's that generate different pipelines on different conditions, is it possible to get those decisions also in the pipeline run to reason about it? Yeah, it's an interesting question. So I think not directly. Yes, there is a way you can do that. What you can do, and I want to be clear, I'm sort of thinking this up on the fly, so I don't necessarily know if this is the best way to do it. The way you would do that is basically create like an object or an array of all the information that you want to store and share. So you might have to come up with some kind of syntax or structure for this that works for you and store that. You would then basically add an echo script using the dynamic pipeline into the first step of your pipeline, which would then just print all of that like kind of decision-making logic that you want to share into the build logs for your pipeline itself. And then it's all going to be there stored inside that pipeline available that you can then track. And so you could see the logic. That might sound a little bit janky because I literally just thought of it as you asked a question. So yes, there are ways to do that. You wouldn't want to output as part of the actual configuration because then it might influence the path of the pipeline. But what you can do is you can store that and then you can output it to the build logs just by writing a script that echoes what you want to the build logs itself. And then they'll be stored and then you can access them. Yeah, I'll actually show you exactly what I'm talking about. I don't know if it had anything, but part of this, I got on the bottom, you can see here it's actually outputting, logs here. So you can just log the full thing and then it'll be there. So it's not perfect, but you will be able to access it in the context of the pipeline and see everything that's going on. And that's a way to help debug. Can we call dynamic pipeline from one of the steps of the static pipeline, or does it have to be before or after static pipeline? So kind of already touched on this. Has to be before, but we are considering the option of allowing you to invoke like child pipelines. And when we do that, you would be able to dynamically generate the child pipelines, which effectively would get the outcome you're looking for. It would just add a bit more structure around it because we don't want to create these infinite chains of like dynamic pipeline running a pipe, which calls another pipeline, which calls another pipe, blah, 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 blah. Use a condition change set. Could dynamic change set make those values dynamic? I'm not perfectly understanding the question, but I think the answer is yes. And if you come along to the next webinar, that's actually what we'll be looking at building out is an app that does some dynamic logic based on change set. And so we'll be looking at selectively executing tests based on change set. And that is all of the questions. And my voice is dying. Thank you, everyone. Really appreciate you all coming along. Appreciate the questions. They're really, really excellent. Sorry for the little hiccup. I'll go back and find out what I did wrong, but we got it working in the end. The code for the working version of the app will be shared with the repository README as well as documentation. And this will all be up on YouTube for you to look at later, so you can play along. Please sign up for the next webinar in a few weeks, because that's where we'll be going into a bit more detail, and we'll be looking at selective test execution workflow, which starts to add a little bit more value to the overall process. So thank you. We'll see you all soon.